Hello, everyone. Good morning, good evening, good afternoon, wherever you are in the world. Welcome to the webinar on how to enable secured bidirectional communication between multiple devices and the Azure IoT Hub. I'm Manny, and I'm responsible for digital sales and strategy at DS Park. And I have with me today a pool of architects headed by our Center of Excellence Chief, Arpit. And so Arpit and team are going to be talking about IoT, Azure IoT Hub, and about a couple of real life use cases as well. Before we start, a couple of things on the webinar, as such, the format of the webinar. So we will do the main webinar, and then you can use the Q&A pane to ask your questions throughout the webinar. Towards the end of the webinar, we'll park about 10 minutes or so to run through your questions and then provide you answers. So there are any answers, questions that couldn't be attended to during the time of the webinar, we will be able to respond to those questions offline. And we will share a recording of the webinar as well as a copy of the presentation that we are using in today's webinar. So moving on to the webinar, for those of you who don't know much about DS Park, we are a CMMI Level 5 company, an IT solutions and services provider headquartered in Edison, New Jersey, with offices in the US, offices in India, and the APAC. We are part of a bigger group, which comprises of WebDunia and EC Medico. We have partnerships with industry-leading vendors like Microsoft, AWS, Sitecore, Covio, Pantheon, and so on. And in terms of the portfolio that we provide solutions. We have our own products. We provide services and implementation of these products as well. In terms of our core focus areas, we focus on cloud, we focus on data analytics, data platform, we focus on IoT as such. And then apart from that, we have various products focusing on industries like publishing, like energy, like jewelry. And we have our own frameworks as such for areas like fleet management, vehicle tracking, equipment tracking, and connected goods. And a lot of these products and frameworks use cloud. They are on popular data platforms, and some of them use the Azure IoT Hub as such. There are going to be a couple of use cases, one from the energy space, one from fleet management, that our pool of architects would be delving further into in today's webinar. And as such, we work with various industries, be it M&E, be it e-commerce, retail, be it publishing, education, energy, ISVs, nonprofits, and so on, in a lot of their digital transformation journeys. So that's for a brief intro about DS Park. These are just some of our customers. So not to take much time into the main webinar, handing over to Arpit. Arpit, can you share your screen and take over, please?
Sure, this is Arpit. So before jumping into what IoT Hub does and why IoT Hub and bidirectional communication using IoT Hub is important, let's first understand what is IoT and why IoT is so important for us. Next slide, please. So the most building block, the basic building block of any IoT solution is data, and data is being generated by things. So as you guys can see on this screen that these are the probable candidates who will generate data for us. So let's take an example of a bus. So if a bus is is being driven by a driver on the road, then the speed with which it is going on is one of the parameters that can be sent from the bus directly to a backend solution. If you talk about an elevator, then on which particular floor is the elevator standing right now? And if the elevator is functional, those are the kind of parameters an elevator can send to the backend solution. If you talk about a smart grid, then a person who is sitting thousands of miles away from the smart grid can come to know about a potential problem with the grid in case of any power failures or the state of the grid. So all these actors in this ecosystem can send data back to the backend systems, which can be analyzed. So the first and the most important thing is to understand things which generate data. Next slide, please, Mani. Okay, moving on to the simple view on IoT. So an IoT solution not just consists of things, but there are four other important actors like the connectivity, data, insights, and actions. So connectivity defines the mode of communication between the devices which are deployed on field with the backend systems. Data is the actual JSON or XML payload that we send from these sensors back to the backend systems. Insights is something that is generated on the basis of the data that the backend system receives, and actions is something that an end user takes on the basis of insights that he sees. So an action can be as simple as looking at a down elevator and then calling up the head of the admin team from that building and notifying them of the problem. An automated action can be sending a push notification on an app in case of any outage. So these are the explanation for the building blocks of an IoT solution. When we design an IoT solution, there are some other terms which usually come up like hot path analytics, data storage, updating devices, on-device analytics, enterprise integration, cost management, and high availability. So throughout this webinar, we'll try to answer and find things which are relevant towards these factors. Next slide, please. Okay, challenges. So there are a few things that people look for whenever they start implementing an IoT solution. So I've noted down seven of them, seven of the most important questions. The first one is how to get started. So it's easy to get swayed away with the notion of doing IoT solution, but then it's very important to understand where to get started. You need to know what kind of data you're going to send, what are the devices you're going to deploy on the field, how much of concurrency do you need to support on the backend services. So these are some of the basic questions. Once you've figured these out, then the second question is how to connect things that are hard to connect. So if there are two different sensors and they want to talk to each other, how do you do that? If you're able to figure that out, then the next question is how do you store so much of data? You're storing data, and then how do you make sense out of that data? So how do you visualize the data? That's the next question. After that, once you're able to visualize it, then which data should be analyzed in live scenario, that is real-time scenario, against which data that can be stored for historical purposes. Of course, anything that needs to be done in real time will have a cost associated with it, and anything that can be done in a historical manner will be a slightly cost-effective solution. The next question is, what about those devices which may not support the standard HTTP protocols, which may be legacy devices? So how do you connect those devices? So edge computing is an alternative that gives you a solution to connect such devices to the backend services or the gateways. The next question we need to answer is about device management. So you've deployed a number of sensors in the field. Now, how do you update those devices? How do you update their firmwares? How do you get data from them? What do you do if one of them is down? Do you have the ability to switch them off and then reboot them? So this is another question. And the last but not the least is how do you scale such solutions? So you may have prepared a solution that caters to 1000 devices at a time. Now, if tomorrow you need to do it for 10,000 devices, how do you handle that 10 times load? So, so any IoT implementation that we do needs to answer these questions to begin with. So this is like a checklist you need to have answers to before you start any implementation. Next slide, please, Mani. So let's talk about some of the use cases where IoT is helping us out in modern day scenario. Next slide, please. So the first one is healthcare. So one of the common trends in modern medical society is doctors being able to track the health of their patients. So take an example of a diabetic patient. If a doctor wants to understand all the fluctuations in the sugar level of a patient during the day or in the week, how do they do that? They cannot just call a person and check for it. So IoT solves this problem by sending such sugar levels on a regular basis from the patient directly to a backend server, which is hosted maybe on the cloud or on premises where the doctor resides. And doctor can make sense out of that information by looking at some BI reports. IoT in smart homes allows us to switch on our AC even before we have gone into the house. So we can come to know about the temperature of the air conditioner in our house, and we can adjust it by sitting in our car when we start our journey from office to the home. IoT in agriculture has been helping us for over 5 to 6 years now in taking out the temperature readings across the different portions of a field. So if you want to make sure that your crop is same in all the places of a vast field, then you can deploy sensors in every 100 meter and come to know about the different variations of temperature, humidity, pressure, the level of water in the soil, and then make your crop uniform. IoT in garbage monitoring systems has actually helped garbage collections companies in the past to do efficient routing. So for example, if your garbage can is only half filled and the company over the time has realized that you're not going to fill it in next 2 days, there is no point in picking it up. You can actually save that cost on the route by routing across that particular bin for that day. So these are some of the common use cases where IoT has been helping us. Next slide, please. Okay. From now, I'll hand it over to my colleague Rohit, who is going to walk us through why Azure is the right solution for doing the IoT implementation in the modern day world. So over to you, Rohit.
Yeah, thank you, Arpit. So hi everyone, my name is Rohit. I am a tech architect and Azure Solution Team Daspark. So first question is like, why Azure? So there could be many reasons. So the one reason to choose Azure is the giant network. So next slide, please. So there is 40 plus Azure regions around the world. And this is even more than AWS and Google Cloud combinedly. So why not Azure now? So when we talk about the Azure's regions, so it means when you are closer to your server, it will communicate more faster. So now assume a person who is at one place and there is a server which is miles away, miles away from that server. So there will be a high latency, means the travel time. Data will be slow. When now assume the same person is very close to their server, so latency will be low. So you can communicate fast. So next slide, please. And the another reason is like why to choose Azure. There is services, lot of services offered by the Azure. So first, we can talk about the some platform services like we have security. So there are varieties of securities given by Azure. You can talk about Security Central. You can use Azure Directories or Key Vault. If you talk about data, we have different varieties. We have different type of data types. So we can store the same data types in different types of data services allowed by the Azure. So you can store SQL databases. You can use document DB, you can use Redis cache, and even the storage blobs. And another thing is analytics and IoT. So you will have different services like IoT Hub, Event Hub. You can store the big data. Even you can do a machine learning. There is a machine learning models. You can use some string analytics. And when we talk about the infrastructure, so you can get virtual machines. You can do your stuffs. Then the dedicated storage, you can use blob, queues, files, and disk, and the data center infrastructure.
So Rohit, is it safe to assume that because of the wide availability of Azure regions all across the globe, and because of the wide variety of services available in the Azure ecosystem, it is a better choice as compared to maybe AWS or Google Cloud?
Definitely.
Okay. Can you quote us any other services which are available in the IoT horizon which helps us in choosing this over maybe AWS or Google?
The first is reason I have told about. Then the second is the varieties. So there are more. You can see hybrid clouds. So this is specific to that Azure things. The Azure SD monitoring and the backup plans, domain services, and operational analytics. You can do imports, export easily. Even you can connect the different hubs easily because they will be in a sync. If you are having the 40 plus regions, so if you are in a one place, you have deployed your business at one place. Now you are sending the data to one hub. Now this will be in a continuous sync with the another hub. So a person with the same business deployed in another country, they will get the data very smoothly. Next slide, please. Now, when we talk about the Azure IoT, so this is something specific given by the Microsoft for Azure IoT services. So when we talk about the devices, there are some microcontrollers, there could be some edge devices given by Microsoft, and there could be sensors. So for connectivity, they have given Event Hub, they have given IoT hubs, even the service buses you can connect. Then for your application business logics, you can use fabrics, use services, even you can run your own functions. And for talking about the storage, for the different data types, you can use SQL databases for your warm data, table blob storage for your cold data, or a warm data for, again, Cosmos DB. And for analytics, you can use machine learning models, or stream analytics, or big data, or a combination of that. Then for presenting those data, you can write your own application, app services, or you can directly get the data on the Power BI, or you can generate a notification on any event of occurred on the analytics. So next slide, please. Now, referenced architecture. So this is something given by the Microsoft itself. So this is standard and recommended. So you can directly use that. So as the Arpit already described about the 3 pillars of the IoT, the first is thing, then insight, and the action. So in the first things, we talk the things like IoT devices, simulators, or accumulators. You can have sensors. All are things which generates the data. So there is another device connectivity given by the Microsoft Edge devices that that can be inside the premises. If you are having the low latency problem or a network problem, you can connect the IoT Edge devices. Now the second question is how to connect all those devices. Say you are having millions of devices, so how will you connect that? So there is another service given by Azure DPS, device provisioning services, which helps you to connect millions of devices without user intervention. Then the cloud gateway. After connecting all the devices, they will generate the data. That data will store in the cloud gateway, which is Azure IoT Hub. Now what after that? Now we have received the data. Now we need to generate the information. So on the second thing, now we talk about the insights. Now insights means to generate the data, generate the information from the gateway. So it will take the information from Azure IoT Hub. You can forward that to stream analytics. This is the stream processing, and you can directly use that data in the UIs to show at your client end or mobile application, or you can directly integrate that with the business integration. Then again, you can have another endpoint as a data transformation. If you need some transformation on the same data, received data, you can again use the Azure functions. The Azure function is capable to store the data, can forward the data to another service. You can store that in a warm path storage in a Cosmos DB, or a cold storage path as a Azure blob. Then for storing that Azure path blob, you can use machine learning on that to generate some information or prediction. So next slide, please. So this is the information flow. So first producers generates the data, then press key money, then that receives that ingest by the IoT Hub. After ingestion, we can subscribe the same endpoint with this stream analytics. So stream analytics will get the data from IoT Hub, then stream analytics we can send the data to SQL database. Now SQL database, after storing the data in the SQL database, the presentation layer will directly connect to the SQL database and show the points or a data or a information real time. Now what about the historical data? So again, IoT Hub is capable to forward the same data to other services, like when you are subscribing with the document DB or table blob storage. So you can send the data, money key please. So that data will be stored in the blob storage and a document DB. Then from that, you can use it for the big data or machine learning. Then from the big data and machine learning, that can be again shown on the presentation layer, like more keys, money, like that. So next slide, please. Now what is Azure IoT Hub? So it is the Microsoft managed services, which is given by Microsoft to use, specific to use for the IoT things. So it is hosted on the Azure cloud, and you can call it the central communication system, which takes the data from the device and even command back the data to the devices. So this is bi-directional. This is bi-directional, and can connect the millions of devices one time. So even you can, this is very secure and bi-directional, so that you can take the data and proceed, give the data to another service, and take back the data to the IoT hub and send the any trigger or any say upgrade software upgradation and all back to the devices. And even this is secure because it is having the identity system, so each device is identical to it. Unique string can be generated from the IoT hub that can be deployed on the devices.
So Rohit, just a question out of curiosity, how is an Azure IoT Hub different from a traditional queue?
So traditional queue takes the data, then forwards it to another system. Then you cannot give a trigger back to the device that the data is received, or if you are having any new software, new version available, so you cannot send back to the device. So Azure IoT Hub is specific to give the data back. Mani, next slide, please. So these are the endpoint which can be directly configured in the Azure IoT Hub. You can take the data from the Azure IoT Hub. It could be a D2C send endpoints or a device endpoint. Then after reading the data on the IoT Hub, you can directly send it to the another services, like you can forward it to the Azure IoT Hub, Azure Event Hub, or a device provisioning systems. So there could be more that can connect the many services. Next slide, please. Then another thing is the device provisioning system. This is something you can call a helper method or a helper service for device provisioning. When you are talking about the security, if you are having the Azure IoT string and you are deploying it in the devices, so it could be hacked or it could be compromised because the string is hard coded in the devices. Rather, what you can do, you can use the device provisioning services given by the Azure. So it helps to check the devices for their identities and connect that device to the IoT hub. And if the device is new, it gets the new string from the IoT hub and deploys that string in the devices, so that the Azure IoT hub and the devices connect with each other.
So Rohit, is the device twin module of IoT Hub in any ways related to the device provisioning service, or is it something altogether different?
Sorry,
The device twins.
A device twins is like the image, you can say mirror. So if you're doing something on the mirror, so if you're manipulating any system, say your device is not connected yet on the internet, so if you manipulate any configuration, anything on the twins, so when the device will connect to the internet, it will be replicated first because you have changed the configure at the IoT hub. So first it will take the configuration first. Say if you have updated the firmware, so it will check for the firmware, then it will connect the IoT hub and it will take the new firmware first before sending the data.
Okay.
Mani, next slide, please. So this is the question which many ask, that IoT hub and event hub, what is the difference between this? So main difference is IoT hub is specific to treat the IoT devices, and event hub is for the bulk devices. So it supports the AMQP, AMP servers, sockets, connections, and event hub do, but MQTT cannot be available in the event hub. Even the device provisioning system, cloud to device message is not available in the event hub, and you cannot have IoT edge services. Next slide, please. So there are some use cases we have implemented. This is one of our escalators. So fleet management is something you are having with, say, whenever you need some location services and location assets, you need a tracking app or something. So this is one of our framework that can be integrated in any system, so that it generates the data, it receives the data, and plot that data in the client application or web app. So if you are having location GPS tracking, if you are having problem with the routing, if you're having the problem with the vehicle pickup and deliveries. So you can use this solution. What advantage you get is it will improve your efficiency and productivity. It will reduce the operating cost. Next slide, please. This is the high level diagram for that fleet management. A truck is generating the data and sending it to the cloud after some processing, and we are sending back to the cloud and plotting the same location on the real time on mobiles and the desktop. Next slide, please. So this is the architecture diagram for that fleet management. Here we are having the moving devices, which is connected with the device provisioning service for the first time. It takes the connection string from the IoT hub and send back to the moving devices. Then moving devices sends the location services to the IoT hub. Then IoT hub can be subscribed by the Stream Analytics. It generates the data and forwards that to the Cosmos DB for the warm storage when we really need that live feedings. So backend services can read the data from the Cosmos DB and send back to the Angular app or your mobile apps. Then the second thing is whenever we need the historical data. So we keeping this historical data in the Cosmos DB generates the cost. So cutting the cost, what we can do, we can store same the data after an interval, say after a day, we can store the same data on the blob storage. Then again, the backend services can read the data from backend service and response to the request of the Angular app or a mobile app.
So what you mean to say is, if we keep the data for longer durations in Cosmos DB, then our bills are going to be higher. So on a daily basis, we are actually transferring the data from Cosmos DB to the blob storage.
Yes, it will not give you much cost, but to cut your cost, you can manipulate your architecture. So keeping the static data, it will not change in the future because it's a static and
right. So for example, if a trip has ended, so you're transferring the data of that trip to the blob storage because it will not change anymore.
Right.
Okay.
Next slide, please. So these are some screenshots of the fleet management. This is the bird eye view where different cars and trucks are located. Here this trips for one cab where we are showing the time intervals in the colors, and this is the real-time plotting of any cab or any fleet. Next slide, please. So then second is the IoT in renewable energy. So I am handing over it to my colleague Atul. Atul?
Hi all, this is Atul. I work as a chief architect for the energy application. Energy application is one of the benchmark application that we have in DiaSpark that was created completely on the Azure IoT. Mani, I cannot see the screen. I see IoT in fleet management.
Hey, Arpit, can you guys take over?
Sure, Mani. Okay, so IoT in renewable energy. So DiaSpark Energy is one of the products that DiaSpark has built, which is built solely on the principles of Azure IoT. The basic feature of this particular product is asset management, and the primary use cases that we've implemented in United States is about deploying a fleet of sensors on solar panels which are generating electricity. So these panels are continuously sending data via the sensors to our backend application where we are accumulating the data and making sense out of it. So for example, in this case, as you notice that the solar field panels are sending data to IoT Hub from where it is getting to Stream Analytics. Stream Analytics is then storing that data to storage blobs and also giving it to Event Hub. So in case if there is a red flag that one of the solar panel is generating, then the Event Hub is sending that data to the backend application, which is then giving it to the consumers. There are some other implementations of this particular product. For example, in the inverter management, in the smart meters, and in the weather stations. So in the case of smart meters, those are sending us continuous readings of the meters. So at any given point of time, if you want to know what is the consumption of the energy in your house, so this product is able to help us. In case of inverter management, if a particular inverter is not producing appropriate amount of electricity or voltages, then this solution is actually giving us those alerts in time as well. We have also implemented the Azure Edge gateways in some factories to get the data from devices which are not able to connect to internet as such. So those devices are sending data to a server, and then from that server, our edge devices are picking it up and sending it to the backend solutions. On the backend, as you can see, we have used Azure IoT Hub. For storage purposes, we have used both Cosmo DB and blobs. Stream analytics is also used, and machine learning is there as well to predict any maintenance related activity that we foresee in the future. Next slide, please, Mani. So these are some of the screenshots. For example, in this screenshot, our product, we are showing the voltages that the different solar panels are generating. And on the right hand side, you can see the number of alerts, the priority requests which are being generated on the field. This slide shows the location of the different farms where our solution is deployed across United States. And then there are some related graphs, some more related graphs about how the solution works. So, Mani, can you please move on to the last slide? Yep. So as you can see, we've deployed more than 40,000 equipments across 1,500 locations, and the data, the granularity of the data with which we are sending it is 1 minute right now. So this particular product completely relies on Azure IoT, and we have received very good results ever since we have moved to it. So earlier we were using a data warehouse solution to do the same stuff, but then after realizing the pros of Azure IoT, we were able to migrate our product with greater efficiency. Next slide, please.
Yeah, Arpit, I think we have come to the end of this presentation anyway. Yep.
Over to you.
So, yeah. So, Arpit, can you look at the question and answer pane, and then can you read out the questions and then start answering as well, in the interest of time?
So I can see a question over here right now, which says if we can explain the cost of Azure IoT Hub, how it gets charged. So to answer that question, there are different tiers in which Azure IoT Hub is, it gets built. There is a basic tier and there is a standard tier. Now, depending on the kind of use case, you can choose different hubs. So, for example, if the number of messages, it basically charges us in terms of the number of messages we can send per day. So, if you choose the basic tier, then at the minimum cost, it will allow you to send 8,000 messages in a day, and the size of each message maximum is 4 KBs. So that's how Azure IoT Hub gets built. I'm waiting for more questions.
Oh, go on.
I'm just waiting for questions, Mani.
Oh, okay, sure. Hey guys, you can use the Q&A pane to ask questions. So feel free. I think we still have maybe 10 more minutes. If need be, we can also extend for 5 more minutes after that. So if you have any questions, please feel free to use the Q&A pane to ask your questions.
Okay, I can see another question, Mani. It says, how do you scale IoT hubs in case the limit goes off for the first IoT hub? So to answer that question, the way we would do it is we will have to be a little practical in this, because one IoT hub unit can only cater to 8,000 requests or 8,000 messages in the basic tier in the minimum cost. So if you want to attain more than 8,000 messages in a given day, then the only solution is to acquire another IoT hub. Right, so you need to provision n number of hubs according to the consumption of messages that you can foresee in the application. Okay, another question is, why would you need to use stream analytics? So to answer that question, stream analytics is basically needed because whenever we get data live from Azure IoT Hub, there are a few things that we need to do in real time. For example, if you have set a particular flag in the incoming messages and you want to send a notification on the basis of that flag, Azure IoT Hub is not capable to do that. It has its own query language, but then stream analytics watches the data in real time, and if it sees that flag is set, then it will send a notification using the Azure Notification Hub to the concerned devices. So that is just one of the use case of stream analytics. Okay, another question is, how do you handle security? So that's a very good question. I would love to answer that. So security is something that Azure promises out of the box. So for example, any communication from the sensors to the IoT hub and even from IoT Hub to stream analytics or any other field is completely governed by Azure IoT Hub. So it's on HTTPS and it's not publicly visible. So, and then IoT Hub gives you the flexibility to set the encryption keys on itself. So any communication from sensor to the hub and vice versa will be encrypted using either MD5 or HSA algorithm. Okay, another question is which protocols, okay, the question says which protocols does IoT Hub support? So IoT Hub in general supports HTTPS, it supports MQTT, and it supports AMQP as well. So the difference between HTTPS and AMQP or MQTT is if you want to do a server-side push, so HTTPS will never allow you. If you want to do something like that, then you'll have to use IoT Hub with either MQTT or AMQP. I think that's it, Mani. I don't see any more questions.
Let's just give it another minute or so to see if we have more questions, Arpit. Hey, Arpit, do you see any further questions coming on?
No, Mani, I don't.
Okay, guys, if you don't have any further questions, so reach out to us if you have an IoT use case where you would need our help on the assessment or solution architecture or the actual implementation of the Azure IoT use case, or even a customer-facing portal that basically could draw data and then kind of build dashboards around IoT data as well. So we have a team that focuses on all these offerings and such. So if you have an IoT use case, need help, please reach out to us. So thanks for joining, guys. I hope it's been useful to you. We'll be sharing a recording of the webinar as well as a presentation. Have a nice one, guys. Take care.